Okay, Collins Maths Frameworking, Book 3.3, Chapter 10, Surface Area and Volume of Cylinders. And we're going to look at the volume of the cylinder first. However, I don't want you to remember what the volume of a cylinder is, what the formula is, because that's another formula for you to remember. I want you to be able to work out that formula when you need it. So you do need to know the formula of a circle, which is, that's the radius. So the area is pi r squared. Okay, but the formula for any prism, so here's a cuboid, which is basically like a rectangular prism, isn't it? A prism is any kind of shape you draw and then you pull it up, like on sort of Google SketchUp or something. So call that length, call that width, call that height. You know the volume of that is length times width times height. Well, let's just pause a moment. It's length times width, which is the area of the end, isn't it? Times the height. And that's true for any shape, even if we did some weird kind of blob shape like that. If we knew the area of that, and then we could times that end area, whatever that number might be, whatever that area is, and then times it by the h, and we get the volume. So the same with the cylinder. We find the area of the circle on the end, which we've said is pi r squared. There's r, and that's h. So the volume is pi r squared h. Okay, let's do a couple of simple examples. So the radius on the first example is 5 centimeters and h is 8 centimeters. So the volume equals pi r squared h. Please write the formula out each time you do these questions. That will really help you remember, even though I said you don't need to remember. It should be second nature after a while. But I do want you to be able to kind of work out that kind of concept if you need to. But do write the formula out. It really will save you a lot of headache, especially when you get towards the end of this. If you were to do this problem solving, that's quite intense. And writing that formula out each time really helps you. So pi r squared h. Pi times 5 squared times 8. Leave pi in as long as possible. So 5 times 5 is 25. 8 of those is 200. 200 pi. Okay. Unfortunately, I left my school calculator at school. It would be good to be using the same type as you. Okay, so 200 times pi equals 628, which is to 3 significant figures, which is good enough, okay? Centimeters cubed. Don't forget the units. Yep, that matches the book. There is a mistake coming up though. Example 2 just says leave it in terms of pi. So it's the same kind of question. Height is 2 centimeters and the radius is 3 centimeters. So the volume equals pi r squared h equals pi times 3 squared times 2. 3 3s are 9, 2 9s 18 pi centimeters cubed. Now that might look weird to you, 18 pi centimeters cubed, but pi is just a number, and that's okay. Often we leave pi in an answer because pi is perfectly accurate, and as soon as I was to put pi into my calculator and I chop some of those numbers off, it's inaccurate. When I say chop some of them off, pi obviously goes on forever, so this answer goes on forever. Even that is inaccurate. So leaving pi in there is the only way to make it perfectly accurate. Now, we've got a slightly different one for example 3. Example 3, we're told the volume and we have to calculate the diameter. And they've drawn it this way. I'm going to draw it upright just because I've got more space that way. So the height is 15 meters and it's asking what's the diameter. Okay, and the volume is 120 meters cubed. So this is something really big, 15 meters. We're talking about some sort of huge, I don't know, thing. Some sort of thing on a construction site, maybe. Right, let's write the formula out. V equals pi r squared h, which is, now put the numbers in, 120 equals pi times r squared times 15. Now let's do our algebra jiggery pokery. These two come down here, or if you prefer, we divide both sides by 15 pi. So that would look like this, 120 over 15 pi equals r squared. Now 120 divided by 15 equals 8. Okay, we tend to put the letter on the left, the unknown on the left. So let's put r squared equals 8 over pi. So I'm leaving pi in as long as possible. Now I want to get the r on its own, so I've got to square root this. So r equals square root of 8 over pi. But I actually need to know the diameter. And the diameter will be twice that. 2 root 8 over pi. Now that's as far as we can go without putting it in our calculator. So we'll put it in our calculator now. Okay, so I'm going to do 8 divided by pi equals. Now I'm just going to kind of go think about this as I do it, because this answer is wrong. I've done this now 2 or 3 times and I'm convinced I'm right and it's wrong. So let's just kind of go through in our heads. 8 divided by 3 and a bit. That's going to be 2 and a bit, isn't it? Yeah, that sounds about right. Now the square root of that, something times itself equals that. It's going to be what, 1 point, I reckon like 1.5, 1.6, 1 and more than half. Okay, so I'm going to do my square root. Okay, so I said 1.5, 1.6. Yeah, that looks about right. And now I need to times it by 2 to get the diameter. So that says 3.19 centimeters. That'll do 3 significant figures. Meters. Whew, careful there. Meters cubed, meters, that would be meters. Okay, that's what I make it. See what you make it. The answer in the book I think is wrong. Now, I just want to pause there a minute. When you get a bit confused about formulas, is that the formula for the volume? Is that the formula for the area? What? Okay, let's just look at the number of dimensions. Feel free to go on with the exercise, but this could be helpful. In fact, let's get a new piece of paper. So let's put some formulas up, all connected with circles. Pi d, 2 pi r, pi r squared h. Okay, diameter, it's a length, it's a number of centimeters, meters, inches, whatever unit you're using to measure. Microns, it's a length. It's a length. Pi is just a number. So this is number times length. It gives us a length. And sure enough, that's the formula for a circumference. As is this. It's the same. 2r gives you d. So we've got a number times a length. That gives us a length. Now this is an area. How do we know? We have a length times length. Well, you'll know from the area of a rectangle. Okay, length times width, but it's a length, isn't it? It's a linear length. Linear length. Length times length gives you an area. Now, this is the formula for a volume. How do we know? Here's another formula for a volume. How do we know? So length times width times height. That's the formula for a volume of a cuboid. So it's 3 lengths, which gives us a 3-dimensional thing. 3 dimensions, it's a volume. And here we have radius times radius. That's a length times a length. Height is a length. Length times length times length. That gives us a 3-dimensional unit. Meters cubed or centimeters cubed. That is a really useful kind of check. If you're in a panic, oh, was that the formula for an area or a volume? Think about how many dimensions it puts your answer in. Off you go.